We'll pass it a value so we can create the first node in the stack. You would have, except with a stack, because you're only adding and removing from the top, you don't have to keep track of what's happening at the bottom, so we can remove that. And then we will also keep track of the height.
So create stack class. We're gonna initialize, define init, so pass value, and then create our node value, and then self dot top is equal to node, self dot height is equal to 1.
And we don't need to make any change here. So now let's build out the stack, and we don't need to make any change here.
Pointing to anything to nice. All right.
Number 4. And then down here we will run myStack dot, it's the number 4, working stack constructor.
So create a node class node, and then we'll class node, we'll initialize it. Pass in self value, self dot values equals value, self dot next is none. Not really pointing to anything yet. Class dot stack will initialize it. Self value. We create a new node here. Create a new node. Pass in the value, and then pass in self dot value, or is it self dot top is equal to new node, and then self dot height is equal to 1. Nice. Oh, here we go. Studying, gaming, code, educational. Talking. So let's update this. So this is 7 recapped of yesterday. I didn't solve any problems, but I started on doubly linked list. I wanted to skip it because I really didn't. It was kind of boring. But I was like, yeah, it was a little boring. So I decided to skip it. So I'm gonna start on. I started on stacks/queues. So what I would do for today is I will start on stacks and queues and try to solve some problems by the end of it. Nice. Okay. So I think this is right. Yep. So let's move on. Now we're going to learn about stack.push, which I assume it's just going to take the push method and then it's just going to add one more to the height, or adding a node. We'll see.
Now let's create our push method, and push is going to look like this. And we're going to push a new node onto the stack, and we'll have top point to that new node. And we'll be able to borrow heavily from the prepend method for linked lists. And just as we had in prepend onto the stack, and we'll have this, and we're going to push, and push is going to look like this.
So
we're going to push a new node onto the stack, and we'll have top.
So new node. So top is going to push.
And we'll be able to borrow
node.
heavily from the prepend method for linked lists. And just as we had in prepend, we have to code for when we don't have any items in the stack. So those are the steps. If you want to code this, go ahead and pause it here. Otherwise, I will get into the code. And there's our node.
Right, so we'll create
we'll
the
code
node.
For an empty stack first, we'll say if the height is 0,
the return none.
like that, like this.
Oh,
height
if it's
is
0,
like this. We're going to have self.top be equal to new node, like this. And then the other possibility is that we have a stack that has items in it, so we'll say else to that existing stack to the same node that top is pointing to. We'll say new node dot next equals self top up, and then we'll say that top is pointing to,
and then
add
top is new node.
The only thing height create
cool.
is to
So yeah, I think I understand this. It seems pretty self-explanatory. We're just gonna define push. We'll push in self and value, and then we'll create the new node because we want to add it to the stack. And then if self.height is 0, so this is checking if the stack is empty. Self.top will point to that new node. Else, new node dot next. So the one we want to push on is going to become the new head. Self.top is now the new node. And then increment the height of the stack by 1 because it's added. Cool. I understand that. And I think that's
right, so I'm gonna
simply
run
just O of 1 time. Since we're just adding it and nothing's really happening, so O of 1 time for that one. Define push, self and value. We're gonna create our new node is equal to node and value. If what is it? New self dot top is equal to none. Then we point the new node to self dot top, right? Self dot top is equal to new node, right? Self dot top is equal to the new node. To new node. Else. So now it's that new node. So we do new node self.next is now equal to self.top, and then self.top is now equal to new node, and then we just self.height plus equals 1. This is a little confusing because it just seems a little repetitive for me since we're setting it twice, since we're pointing it twice, because it's like new node.next, the pointer is going to be pointing to self.top, and I guess we just move the self.top to the new node. I mean, I guess it does make sense. So yeah. Nice. All right. So popping, I want to say, let's see, this one is just O of, big O of 1 time, right? Because we're not really iterating through the list or anything.
Our pop method. Let's bring up our stack like this. Pop is going to be the removal of that top node.
So I guess pop is also just O of 1 too.
And then you have the top pointer point at the next node down. And then, of course, we're going to return that node that we popped from the stack. And then we also have to code for this situation where we don't have any items
top is
in the stack.
Equal to none.
So if you're going to code this, go ahead and pause it here. Otherwise, I will get into the code. So we'll start this off like this. We'll say pop. We don't pass it any arguments. And we'll code for this situation where we have an empty stack first. We'll say if the height is 0,
return
none. Otherwise, we do have items in the stack like this.
So then you would just want to point.
And we want to return that top node. So we're going to need a variable to point to it. So we'll say temp equals self.top, like that. Once we've done that, we can move top down to the next node. So we'll say top.
Self.top is equal to self.top.next. Okay. So now temp becomes a new
.next.
That old variable. That old.
So now we need to remove that node
index
from the stack. So we'll say temp.next equals none. That is temp.next equals none. And that removes that from the stack. Now let's look at this in with the rest of our code.
All right, let's create a note. So we'll create the method. So we're checking here if self.height is equal to 0. So if it's empty, then we just return none because there's nothing to pop. And then we'll temp is equal to self.top. So creating a variable here to point to the top. Self.top. Self.top is now going to be equal to self.top.next. So kind of moving it down the list. And then temp.next is equal to none. Right, because this is going to remove the node from the list. Okay, that seems pretty self-explanatory. All right. So define pop, pass in self. So right here we'll check if self dot height is equal to 0, then we return none. Else, we create temp is equal to self dot top, and then self dot top is now going to be pointing down to the new one, so self dot top dot next, and then we point temp dot next is equal to none, because this is going to be pointing, this is going to be removing the node from the list. So we check it, return none, sub dot top is equal to sub dot top dot next, temp dot next is none. Nice. Oh, let's see what happened here. None type object has no value. Did I have to pass
This
in?
line of right, so I'm gonna
Oh, I did have to pass in. Oh, no, this one.
and to take a
Oh, self.height, remove one. That's what I forgot. And return the temp. We have to return the value. Self.height minus equals 1. Psh, I don't know why it does that. I don't know what this is. Return temp. Okay, so let me add that to my notes real quick. I forgot to. So decrement the list and then return temp. Nice. Cool.
and to take a look at what's in that node, I'm going to come up here.
Hold on, I'll be right back. I'm gonna grab some chips. right. Alright, so let's get back into it.
I'm going to type temp.value, and now I'll run it
So
again.
this is the pop method. We just finished that one. So I guess that's all there is for stack. I know for queues, it's the opposite of stack. So instead of stack being last in first out, this was going to be first in first out.
Let's look at queues. And queues are something we're all familiar with. We join a queue whenever we get in line. And then there's other people that can get in line behind us called FIFO. First
first
out.
in first out. I mean,
In DQs, so for something to be a queue, you add on one end and you remove on the other end. With a list, removing and adding from the end is O of 1, but on the other end, removing and adding is O of n. So if you have a queue, let's say we're going to add on this end and we're going to remove on this end, we have one way that is O of n and the other way that is O of 1.
O of 1.
Likewise, if we add on this end and remove on this end, we still have one end that's O of n and one end that is O of 1. Now let's compare this to a linked list. With
A linked list. Adding this on.
linked list, removing is O of
O
n.
of 1.
on the
Yeah,
end,
this one's O of n.
but adding it back on is O of 1. On the other end, removing is O of 1, and adding it back on is also O of 1. So you have 3 O of 1s here and 1 O of n. And that means what you don't want to do is you don't want to DQ from this end. You want to NQ from this end and DQ from this end because both of those
Are
O
O of 1.
With a linked list, we call these head and tail. A change that we're going to have for it to be a queue is we're just going to call these first and last. And that
Nice.
is our intro to queues.
So now let's look at the queue constructor. Here.
All right, now let's build our queue constructor. So we're going to build one of these, but we're going to represent it like this. And in order to build this, the first thing we have to build is a node, which really looks like this, and the constructor looks like this. So this is the same node constructor that we used with linked lists, and the same one we used
For
stacks.
For stacks, yeah.
Now let's start off our queue class.
So, we'll just have to create the node again. So class node will pass it itself in value, where self dot value is equal to value, and then self dot next. So we're just pointing is equal to none, and then we can create the queue class self value. I'm assuming we'll have to create a new node here. So new node is equal to node value. Nice.
Stacks. Now let's start off our queue class and start building the constructor. So the first thing we're going to do in the constructor is build a node like this. We'll pass that a value, and that creates our node. And then we'll say first and last are equal to the new node.
So first and last are both pointed to the new node. So this is kind of exactly like linked list, where the tail and the head are both pointing at that node. Is equal to new node, self.last is also equal to new node.
like that. And the length is going to be 1. And that is all of the code for our constructor.
Nice.
For our queue. All right, that do constructor.
So let's go down to the exercise. So let's create that node class, which will pass in self and value. Self.value is equal to value, and then self.next is equal to none. And we'll create our queue class, which also passes in self and value, where this one creates that new node. So node, or new node is equal to node value. And then self.first is equal to new node. Self.last is also equal to new node. And then we'll increment the height because we have a node added. Let's run that. Class queue. What?
So I'm going to run this.
Oh, we didn't do define init. I'm so stupid. That's why I didn't have that's why I didn't have self and value. So we can take that out. Okay, there we go. No, I was so confused because I was like, what is happening? So self and value. Create our queue class. Let's do this again. Define init. Self and value. Self dot what is it? Oh, new node. New node equal to node value. And then self dot head, or is it self dot head is equal to new node? Self dot first is equal to new node. Self dot last is equal to new node. And then we'll increment self dot height by 1. Is it height or is it length? Length.
All right.
Oh, so self dot length is 1. Cool. Let me copy this. And then I'll redo that. And then we can move on to the next one.
So now let's build our enqueue method. And enqueue is just getting in line. So the way we're going to do enqueue is going to look like this. And that will add that onto the end. The way we're going to do enqueue is going to look like this. And that will add that onto the end of our queue. So this is one of our possible queue is going to look like this. and that will add that onto the end of our queue. So this is one of our possible scenarios for adding an item into the queue. The other one is if we have an empty queue. In this case, we'll have first and last point to that new node. So if you're going to code this, go ahead and
So define in queue, pass in self, and then I guess the value.
pause it here. Other value to create a node.
So create
Like
that node.
So the first scenario we'll code for is if we have an empty queue where we're going to have first and last point to that node. In other words, it is the first and last item in line. So to do this, we have to test to see if the queue is empty.
If it's none.
And we'll do that by saying
So if
first is
first
none, we'll have first be set equal to the new node like that. And we'll also have last set equal to the new node like that. So let's add this in with the rest of our code. So that is for if we have no items on the list. If we already have items on the list, we'll say else. Let's build out this else statement.
So
we'll
else
say
we can sell
last dot next equals new node. That is last dot next.
And then new node equals self dot.
Then we'll say last equals new node. And we'll move that over, and that adds that onto the end of our queue. So let's add this code in with the rest of our code like that. And the only thing left to do is to increase the length by 1. So we'll look at this code in a moment in VS Code, and when we do, we'll build.
Nice. That one seems pretty self-explanatory too, I think. Define enqueue self and value. So first, we want to create the node. So new node is equal to node, passing that value of the node. And then we'll check if the list is empty. So if self.first is equal or is none, then we can set self.first is equal to that new node. Self.last is also equal to that new node. Else, what we can do now is, since it's at the last, we can point self.last is now equal self.next. Next is now equal to that new node. So now it's pointing to that new node, and now all we have to do is set self.last is equal to new node, and then increment the list by 1 because we just added it. Got 1. Test.
I'll run this again. And with this. And this is where we will in-queue a second node.
Oh, was it in the if statement? It was. Nice. Cool. On the DQ.
And all we're doing here is running DQ. That with this will be needed. And we'll say DQ. We'll say if the length is 0.
So we'll define DQ.
We will return none. And we'll remove that. And let's do this for
Pass
one node.
itself.
So it doesn't matter if we have 1 or if we have 2 or more. That means we're one item for none.
So if self.length is equal
And
to
let's
0,
do this for one node. So it doesn't matter if we have 1 or if we have 2 or more. That means we're going to return a node. So we need to have a variable point to it. So we'll say temp equals
is equal to self dot
self.first.
first, right? So having a
Moving
temp
one item,
variable,
we'll say if the length is 1, we set first and last equal to none, just like that. So let's look at this in with the rest of our code. So far we have written code for if we have 0 items in our queue, and if we have 1 item.
So
now
else,
we're going to do this for 2 or more items. So let's focus in on the else, and we'll bring this up.
so all we had to do is move first is equal to first.next. Temp will point, or first.next, or temp.next is going to point to this. We'll set first.next to point to none.
It's already pointing to self.first.
Right, because we're going to remove it and then
so the
just
first
set
thing we're going to do is move
the
that
new variable
first
here.
pointer over 1. So we'll say first equals first dot next. We'll do that with this line of code here. First equals first dot next, and that is going to move that over. Then we'll say temp
first
dot
equals
next
self
is
dot
none.
first dot
We'll
next.
do that with this line of code here. Temp dot next equals none. And first pointer over 1. So we'll say first equals first dot next. We'll do that with this line of code here. First equals first dot next. And that is going to move that over. Then we'll say temp dot next is none. And we'll do that with this line of code here. Temp dot next equals none. And that removes that from our queue.
And
So
decrements
let's look
it.
at this with the rest of our code.
Yep. So self dot right and return temp. Cool.
And we'll build
Cool. Alright, let's get this working. So define DQ, pass in self. So first we want to check if the node is pointing to 0, right? So if it's just length 0. So if self.length is equal to 0, then return none, right? Because there's nothing to return. Elif self dot length is equal to 1. Then we want to point self dot first to what? To none. To self dot last equal to none. Else, we create our temp variable. I guess I'll create up here. Temp is equal to self dot first. Else, we set self dot first is equal to self dot first dot next. We point temp dot next is equal to none. Which removes it out of the list, right? So then we just decrement it, right? So self dot length minus equals 1, and then return temp. Nice. Pushing an item on? I'm pretty sure it was, yeah. 01. Removing it though from a queue. It should be 01. Yeah. So it looks like those are all true.
that. So our stack is going to look like this.
And a stack with an empty list. So if I go back to the constructor for stack class, copy this. So instead of using a node, we just create a list, right? Because then, so we don't need this. Then we don't need this. Is it just stack, or is it self.value is equal to this? Is that right? How does this work? Boom. Okay. Okay. So define push self and value. Do we just do self dot stack underscore list dot append value? Okay, cool.